Good day. We're going to try doing some graphs when we apply different stresses to an equilibrium. And so you can see A, B, C, D, and F represent these different stresses. And I've tried to make these different colors so that we can keep track of what's happening to each of the chemicals over the course of these stresses. So first thing is I need to get a good pen color, so let's see if we can get blue. And we'll just put that's supposed to be a flat line there. And then I need green, so we'll put a green line right around there. And we'll try magenta. We'll try magenta here. So these are all supposed to be flat lines. All right, now we add SO2. So that is a stress just to the SO2. And we're going to make it go up like this. Since it went up like so, well, we'll make it go up a little bit more. This is somewhat qualitative. Then we know it's going to curve down to a new equilibrium, and it has to end up above where it was. Now the O2 in green, okay, the O2 is going to drop by half the amount, so it's curving. So its drop here is half of what the B was, because that 2-to-1 ratio. And the SO3, will curve up by the same amount this dropped by. So it's going up more than the O2 dropped. Now we have arrived at B, and it says we increase temperature. So by the way, I should have said that what happens here is the O2 is going to drop, and the SO3 is going up after that stress. Now, increasing temperature, so that goes up. So the equilibrium will be shifting left. So we'll be getting more SO2, and we'll be getting more O2, and we'll be dropping the SO3. And so since I'm in the magenta color, I might as well drop it, and that's supposed to be curving. And now we'll get a blue, and this will go up by the same amount. Come on. Whoops. Okay. So that's going up by the same amount. This went down, and then the O2 again will be half the amount. So let's find that slimy green. So it will just go up a little bit, but that is supposed to be half the change that this was. And we've arrived at C. Now we add a catalyst, and the equilibrium just carries on merrily. So these should just be flat lines. That was semi-decent. And this one is flat. So catalyst, we stay at the same equilibrium position. Now we're adding SO3, and hopefully I'm still in magenta land. So SO3 went up. And hard to see, so I'll just widen it. And then it will drop. And again, it has to stay above its original position. And the blue will increase by the same amount and flatten out. So that increase, same as that drop. And this will increase by half the amount. Now we're removing O2. So instead of going up, the O2 is going down. So the O2 is going to first drop, and then it will come up a bit, but not as high as it originally was. And the O2 will go up twice as much as this went up. And the SO3 has to drop by the same amount. that the SO2 went up. Now, increasing the pressure. When we increase the pressure, all of these things are going to go up. Then we have to decide which way are they going to go. Well, if we increase the pressure, it favors this side. 2 moles of gas compared to 3. So this will go up, and then it will keep going up and flatten out. And the blue will drop by the same, well, it's got a first spike, so it spikes because of the pressure increase, and then it drops by the same amount that the SO3 went up. And somewhere there's green, and this one will spike, and then it will decrease by half the amount that the blue decreased. So what am I trying to show? When we have a concentration change, and we had 3 of them, we had 1 in A, 1 in D, and 1 in E, we either get one thing going up, like here and here, here and here, or one thing dropping, and the rest stay the same, and then they move to equilibrium. When we increase temperature, they all curve to a new equilibrium. So increase in temperature happened at B, so that was a bit of a blunder. So there's our curving. And when we change the pressure, they all will spike or they'll all drop before curving to equilibrium. And we love a catalyst because the horizontal lines just carry on that way. Now you can see this wasn't very quantitative. For quantitative, you'll have to do calculations and things. But this is showing you the general tendencies. With a pressure change, you could actually drop below where you started. That's allowed. But remember, for concentration, here we had a spike. We had to end up above where we started. And here we had a spike, had to end up above. And here we had a drop, and we had to end up below where we started there. So those are some of the key ideas, and that was my best attempt at some free hand drawing. And we'll just finish with my practice printing, which is really improving year by year. Well, that's it.